In an earlier concept, you learned to factor quadratic expressions that looked like this: x squared minus 8x plus 16. And this quadratic expression factored into two binomials. And it factored into x minus 4 and x minus 4. Or you could have written it as x minus 4 squared. Either way, this quadratic expression of 3 terms was factored into two binomials. You can also factor expressions that have more than 3 terms, or where the first term isn't 1. In this case, the first term is 1. How would we do that? Take a look at this expression. Now you may already be noticing that there are 4 terms in this expression. We have 4a, 4b, ac, and bc. Now, in an earlier concept, you factored out greatest common factors from monomials and polynomials. We can use a similar system here, and we're going to group the things that are in common. Let's take a look. First, you could almost look at this separate from this, because 4a plus 4b both have a 4 in common. Let's factor that out and leave us a plus b. Now let's factor this second part of the expression, ac plus bc. That has c in common. Let's factor that out, leaving us with a plus b. Now you might already have noticed that a plus b is common in both, so we only have to write it one time. And now we can put the rest of the expression together with 4 plus c. This is our completed work. This expression has now been factored. Here's another expression with 4 terms. Let's look at what's in common and see if we can factor it. And we can say that 9x plus 9y has a 9 in common. Let's factor that out. And when we do, it leaves us with x plus y. ax plus ay has an a in common. So we can factor out the a, leaving us with x plus y. Notice that x plus y is common in both, so we only need to write it one time. And we have 9 plus a as our other binomial. Now we have factored this expression into two binomials. Remember that to factor by grouping, we look for common factors and we group terms according to common values. Take a minute to write this down in your notebook.